Right, so in this example I'm going to do the difference of two squares, and we're going to look at factorizing using the difference of two squares. So the difference of two squares just means that you've got a term squared minus another term squared, and the general rule is it's the first term plus the second one times the first term minus the second term. This is your general rule here, but if you want to check it, you can just multiply these two out and you will end up with this here. So for example, you end up with x times x minus y plus y times x minus y. If you multiply these out, you get x squared minus xy plus xy minus y squared. This and this will cancel, plus xy minus xy will cancel, and you just end up with x squared minus y squared. So you end up with what you started with when you multiply these two out here. So this is our general rule here that we're going to use throughout these examples. So let's start with a fairly basic one. Let's take x squared minus 36. So we have an x squared minus 36. That may not look like the difference of two squares at first, but you can actually turn them into an x squared minus 6 squared. 36 is just 6 squared. So now we have something squared minus something squared. That's just going to be the first term plus the second term, first term minus the second term. So these two are factors of x squared minus 36. Let's look at another one. Let's take 25x squared minus 49. So in this case, again, it may not look like the difference of two squares, but this here, if you look at this term here, it's a 25x squared. The square here is squaring the x. This square here is not squaring the 25. So we've got to turn this entire term here into something squared. So if we take 5x, put brackets around it and square it, we will end up with 25x squared. The square here now is squaring everything in this bracket. It's squaring the 5, which will give us 25. It's squaring the x, which will give us x squared. So this term here is exactly the same as this term here. Our 49 then is just 7 squared. So this will just give us 5x, the first term, plus the second term, the first term minus the second term. So these are our factors of this here. Let's look at another one then. Let's look at 36x squared minus let's say 100 y squared. Okay, well again we need to change these two terms into something squared. Again, these squares are only squaring the x, and this square here is only squaring the y, so we need to change the first one into 6x squared and the second one into 10y all squared. This will give us 6x plus 10y, 6x minus 10y. So if we multiply these out, we should end up with this here. Okay, let's try another one. Let's take again, let's say we'll take 36 x squared y squared minus let's say, I don't know, 121, and we'll say m squared. Okay, so in this case we need to write something down that we can square that will give us this term here. Well, the 36 is just 6 squared. The x squared is just the x. We can square that. The y is just a y. We can square that. So if we put those in brackets and square it, square the 6, you get 36. Square the x, you get x squared. Square the y, you get y squared. The second one is just 11 squared. So that's just going to be, again, the first term, which is 6xy, plus the second term, the first term, which is 6xy, minus the second term. Okay, so we'll do one last one. Let's take 121 y to the power of 4 minus let's say 169, and we'll take m to the power of 4 as well. Now, in this case, it may not again look like the difference of two squares, but you know that 11 squared will give you 121, 13 squared will give you 169. But what about the y to the power of 4 and the m to the power of 4? Well, let's look at that. We know that we can square 11 to give us 121. What can we square to give us y to the power of 4? Well, say we take y squared and square it. Y squared times y squared, I'll do it here, y squared multiplied by y squared. Add the powers, add the indices, you get y to the power of 4. So we can just square the y squared to give us y to the power of 4. Same here, minus 169 is just 13 squared. We have an m here, we'll square it and we'll square it again. When you have a power of a power, one of the laws of indices is that you multiply the two powers here. So 2 times 2 is 4, 2 times 2 is 4. Or if you take the m squared is just m times m. Multiply it by itself, gives you times m times m. Again, that's just m to the power of 4. So m squared times m squared will give us m to the power of 4. Okay, so now we've got two things squared, two terms squared here, and subtracted. So that's the difference of two things squared, the difference of two squares. So we write the first term, which is 11y squared. We subtract, or well, we'll add, say, it doesn't really matter which way you do this, but 11y squared, add the second term, which is 13m squared. Multiply that by the first term, which is 11y squared. Now we're going to subtract the second term. So this here then is what we get when we factorize this expression here. So if we multiply these two out, multiply these two brackets out, we will get this here.